Welcome to Astronomy Daily, where we bring you the latest news and developments from the world of space and astronomy. I'm your host, Anna, and we have quite a packed episode for you today. We'll start with a bittersweet farewell to Europe's Gaia Space Telescope, which has mapped nearly 2 billion stars in our galaxy over the past decade before being officially retired this week. Then we'll look at NASA's decision to reassign several astronauts from Boeing's troubled Starliner program to SpaceX's Crew 11 mission, as Starliner's return to flight gets pushed further into the future. We'll also cover a canceled cargo mission to the International Space Station due to spacecraft damage, and dive into China's ambitious new planetary exploration roadmap that stretches all the way to Neptune. And finally, we'll explore a fascinating discovery from the James Webb Space Telescope, the first ever observation of auroras on the ice giant Neptune, revealing unexpected details about the distant planet's atmosphere and magnetic field. So buckle up for a journey across our solar system and beyond as we explore the latest frontiers in space science and exploration. Europe's star-mapping Gaia Space Observatory has officially ended its mission after more than a decade of groundbreaking observations. On March 27th, the European Space Agency's control team in Paris shut down Gaia's subsystems and maneuvered the spacecraft into a safe retirement orbit around the Sun. The move came after ESA had already shut down Gaia's science operations in January when the spacecraft's fuel reserves were nearly depleted. The final retirement orbit was carefully calculated to ensure Gaia remains at least 6.2 million miles away from Earth for the next century. Despite its active mission coming to an end, Gaia's scientific impact will continue to unfold for generations. As Gaia mission manager Uwe Lammers eloquently put it, "We will never forget Gaia, and Gaia will never forget us." Since its launch in 2013, Gaia has charted the positions of nearly 2 billion stars, creating the most precise three-dimensional map of our Milky Way galaxy ever made. Its contributions to astronomy have been immense, from discovering evidence of galactic mergers to identifying new star clusters, tracking hundreds of thousands of asteroids and comets, and even helping scientists discover exoplanets and black holes. The team releases large batches of mission data every couple of years, with the next major release, Data Release 4, planned for 2026. Even more exciting, the final Gaia Legacy catalogs are scheduled for release around 2030, ensuring that Gaia's contributions will continue shaping our understanding of the cosmos for decades to come. Decommissioning such a sophisticated spacecraft wasn't a simple task. Spacecraft operations engineer Giulia Fortuno described the mixed emotions involved. "I have mixed feelings between the excitement for these important end-of-life operations and the sadness of saying goodbye to a spacecraft I have worked on for more than 5 years." The Gaia team had to systematically dismantle the spacecraft's built-in redundancies, features designed to help it survive extreme conditions like radiation storms and micrometeorite impacts. This meticulous process ensures that Gaia won't accidentally reactivate if its solar panels catch sunlight in the future. As this remarkable mission comes to a close, the astronomical community celebrates Gaia's legacy as what project scientist Johannes Salman called a unique treasure trove for astrophysical research that will influence almost all disciplines in astronomy for generations to come. Next up in today's news, NASA has made significant changes to its astronaut assignments, announcing Thursday evening that several astronauts previously slated for Boeing's Starliner missions will now fly on SpaceX's Crew 11 mission to the International Space Station. Leading the Crew 11 flight, now scheduled for no earlier than July 2025, will be NASA astronaut Zena Cardman. She'll be joined by NASA astronaut Mike Finke as pilot, along with JAXA astronaut Kimia Yui and Roscosmos cosmonaut Oleg Platonov as mission specialists. These 4 astronauts will have the honor of being aboard the space station during the 25th anniversary of continuous human presence on the orbiting laboratory, which began when Expedition 1 docked on November 2nd, 2000. This reassignment represents yet another setback for Boeing's troubled Starliner program. Cardman was previously assigned as commander of the Crew 9 mission before being removed from the Starliner crew flight test mission last August, when NASA decided the spacecraft would return to Earth without crew. Mike Finke's journey has been particularly complicated. Originally named to the Starliner crew flight test back in 2018, he was later designated as part of the cadre of Starliner astronauts and then moved to the Starliner 1 mission as pilot in 2022. Now he finds himself reassigned to SpaceX's Dragon spacecraft. JAXA astronaut Kimia Yui who had been training with the Starliner team and was likely intended for a Starliner mission, has also been shifted to the Crew 11 roster. Meanwhile, Boeing and NASA continue working through technical challenges with the Starliner spacecraft. According to NASA, more than 70% of the flight observations and in-flight anomalies from last summer's test mission have been addressed. But the major in-flight propulsion system anomalies remain outstanding issues that likely won't be resolved until further into 2025. A new testing campaign is planned for this spring and summer at the White Sands Test Facility in New Mexico, focusing on the propulsion issues that prompted NASA's decision to return the Starliner without astronauts. Engineers will conduct integrated firing of key Starliner thrusters within a service module doghouse to validate thermal models and develop potential upgrades for the propulsion and thermal protection systems. NASA is weighing its options for Starliner's next flight. While still planning for a crew-capable post-certification mission, the agency is also considering a cargo-only option depending on its needs. Steve Stitch, manager of NASA's Commercial Crew Program, indicated the next Starliner flight would likely occur in late 2025 or early 2026. These developments represent a continued shift in NASA's commercial crew strategy, with SpaceX's Dragon spacecraft taking on additional missions while Boeing works to resolve Starliner's technical challenges. And in more NASA news, in a disappointing turn of events for NASA's cargo resupply schedule, the space agency has called off a planned mission to the International Space Station due to damage discovered on the Northrop Grumman Cygnus spacecraft. The mission, designated NG-22, was scheduled to launch this June from Florida's Space Coast, carrying several tons of critical supplies, including food, fuel, and scientific equipment, to the orbiting laboratory. The problems began on March 5th when NASA announced that the spacecraft's shipping container had sustained damage during transportation to the launch site. At that time, mission teams were hopeful that the Cygnus spacecraft itself might have remained intact despite the damage to its container. However, after completing a thorough inspection, NASA confirmed on Wednesday that the cargo module itself had also been damaged. Following initial evaluation, there also is damage to the cargo module, NASA officials stated in an emailed announcement, leading to the difficult decision to cancel the June flight entirely. The good news is that this cancellation isn't expected to significantly impact the astronauts aboard the space station. NASA had already taken precautionary measures by planning to send additional food and other consumables on SpaceX's next cargo flight, which is scheduled to launch next month. Northrop Grumman and NASA aren't giving up on this particular Cygnus spacecraft just yet. According to NASA's statement, the International Space Station program will continue working with Northrop Grumman to assess whether the Cygnus cargo module is able to safely fly to the space station on a future flight. In the meantime, Northrop Grumman is already shifting focus to its next mission, with NG-23 now scheduled to launch no earlier than this fall. The current Cygnus spacecraft, NG-21, remains berthed at the ISS, but is scheduled to depart tomorrow. Unlike SpaceX's Dragon capsules, which are designed to survive re-entry and be recovered after splashing down in the ocean, Cygnus spacecraft are expendable. At the end of their missions, they're loaded with trash and other unneeded items from the station before being released to burn up during re-entry into Earth's atmosphere. China has unveiled an ambitious new roadmap for deep space exploration that places a strong emphasis on the search for extraterrestrial life and studying planetary habitability. This strategy, recently shared by the country's Deep Space Exploration Laboratory, outlines a series of missions spanning from 2028 to 2039 that will take Chinese spacecraft across our solar system. The journey begins with the Tianwen-3 Mars sample return mission, scheduled for launch around late 2028. This already approved mission aims to collect samples from the Martian surface and return them to Earth, with one of its primary objectives being to investigate potential traces of past or present life on the red planet. Hot on its heels will be Tianwen-4, planned for 2029, which will venture to the Jupiter system and eventually enter orbit around Callisto, one of Jupiter's largest moons. This mission could yield valuable insights about potential ocean worlds and habitability conditions in the outer solar system. Around 2030, China plans to build a ground simulation device for planetary habitable environments, allowing scientists to recreate and study conditions that might support life elsewhere in our solar system. Perhaps one of the most intriguing missions on the roadmap is scheduled for 2033, a spacecraft designed to collect particles from Venus's atmosphere and return them to Earth. This mission could help scientists better understand the microenvironment of Venus, a planet that might once have been much more habitable than it is today. By 2038, China aims to establish a Mars research station focused on in-situ resource utilization and conducting long-term environmental and biological research. While there's no indication this facility will host human crew initially, it represents a significant step in China's long-term Mars exploration strategy. The most distant target in the roadmap is Neptune, with a potential nuclear-powered mission launching around 2039. This ambitious mission would study the ice giant's ring system, atmosphere, and its fascinating moon Triton, exploring the habitability of the Neptunian system and searching for other potential ocean worlds. While some of these missions are already approved and in development, others face significant technological and economic hurdles. For example, a mission to Neptune would require China to make considerable advances in nuclear power for deep space applications, ultra-long distance communications, and spacecraft designed for extended mission lifetimes. This roadmap demonstrates China's growing ambitions in space exploration, and particularly in astrobiology. Combined with China's Earth 2.0 inches exoplanet observatory scheduled for launch in 2028, which aims to detect Earth-like planets around other stars, it's clear that the search for potentially habitable worlds and signs of life beyond Earth has become a central focus of China's space program. Let's pay the JWST a visit now. In a remarkable astronomical breakthrough, the James Webb Space Telescope has captured the first ever clear images of auroras on Neptune. This significant discovery has eluded scientists for decades, as previous instruments aboard NASA's Voyager 2 probe and even the Hubble Space Telescope weren't able to definitively observe this elusive phenomenon on our solar system's most distant planet. The auroras appear as lighter blue or cayenne areas against Neptune's deep blue atmosphere. Unlike Earth's auroras, which are concentrated around our magnetic poles, Neptune's auroral activity occurs at mid-latitudes, roughly equivalent to where South America would be positioned on our planet. This unique distribution is due to Neptune's unusual magnetic field, which is tilted by a remarkable 47 degrees from the planet's rotation axis. What makes this discovery particularly exciting is that it required Webb's exceptional infrared sensitivity to detect. Henrik Mellon of Northumbria University, who led the research while at the University of Leicester, expressed his astonishment at the clarity of the images, noting that the detail and definition of the auroral signature was truly shocking. The basic mechanism behind Neptune's auroras is similar to Earth's northern and southern lights, solar particles interacting with the planet's atmosphere, but the configuration and conditions are distinctly different. The location of Neptune's auroral glow directly correlates to where the planet's magnetic fields converge into its atmosphere, explaining why they appear far from its rotational poles. Perhaps equally surprising was what Webb's data revealed about Neptune's atmospheric temperature. For the first time since Voyager 2's 1989 flyby, scientists were able to measure the temperature at the top of Neptune's atmosphere, discovering it has cooled dramatically by several hundred degrees. In fact, the temperature recorded in 2023 was just over half of what it was in 1989, which may explain why these auroras have gone undetected until now. This discovery opens an entirely new field of study regarding ice giant planets and how solar particles interact with their atmospheres, providing astronomers with fresh insights into these mysterious distant worlds. Well, that brings us to the end of another fascinating journey through the cosmos. From the final retirement of Europe's Gaia telescope after its remarkable decade mapping our galaxy, to the ongoing challenges with Boeing's Starliner prompting NASA to reassign astronauts to SpaceX missions, we've covered quite the astronomical landscape today. We've seen how even the best-laid plans can change when hardware gets damaged, as with Northrop Grumman's Cygnus spacecraft. We've explored China's ambitious roadmap for planetary exploration, with its focus on finding habitable environments and possibly life beyond Earth. And we've marveled at the James Webb Space Telescope's groundbreaking discovery of Neptune's auroras, hiding in plain sight for decades until now. The universe continues to surprise and inspire us with each new discovery and mission. Whether it's mapping billions of stars or detecting the faint glow of auroras on distant ice giants, our quest to understand the cosmos keeps pushing forward despite setbacks and challenges. I'm Anna, and it's been my pleasure to guide you through today's space news. If you'd like to stay updated on all things astronomy, please visit our website at astronomydaily.io, where you can find our constantly updating newsfeed and listen to all our episodes anytime. For more astronomical content and updates, you can also find us across social media. Just search for Astro Daily Pod on X, Facebook, YouTube Music, and TikTok. Until next time, keep looking up and wondering about the mysteries that await us among the stars. See you tomorrow.